All right, welcome to another session of DGX Compare. This will be a quick video. We're comparing Qwen 3635 billion today. They're both quantized down to 4-bit. And the top system is the DGX Spark over there. And the bottom system is this MacBook Pro with an M5 Pro chip, and 48 gigs of RAM. And today we're doing a quick comparison of what it's like to run exactly the same model on a piece of hardware that has really fast memory bandwidth, which is the MacBook Pro, or not really fast, but faster than the DGX Spark. But the DGX Spark has really fast prefill, which is the time it takes to grab the query before it comes up with the answer and passes it on to the processor for decode, or kind of showing to the user. And in this specific case, the MacBook Pro is running 300 gigabytes per second, and the DGX is running at 273. So they're pretty close, but the prefill is what's different. But in terms of these very small models, the 10% difference in memory bandwidth can be significant because there's not a lot of data that's being spit out, and small piece of text, it's like lightning. So yeah, let's give it a try. So the query, tell me all about Tyrannosaurus Rex, and let's try both. But before anything else, we're running here at around 85%, 86% on the Mac, and on the Spark we're running 87%. So right about on par. I'm going to press the Mac first, but immediately after I'll be pressing the Spark. Ready, set, go. Okay. It's a horse race, and there we go, right? The Spark has gone ahead and completed prefill on the Tyrannosaurus Rex, and it's spitting it out, and it's really fast. It's probably 50, but wow, you see that? The Mac took a lot longer for prefill, but when it was spitting out the data or the information, it was instantaneous. It was like lightning. So I would say that it's more than 10% in terms of speed. Oh, so before anything else, this is actually running off of silicon, meaning we're not in a container. It's running straight using MLX. And when you use a model that's fine-tuned for MLX, it can get really fast. Now, on the Spark, it's also fine-tuned for the Spark, but a fine-tuned model on slower hardware or slower memory is not going to compare to a fine-tuned model on fast memory, right? So yeah, let's do another query. How does T-Rex compare to another large theropod? And on the top, how does T-Rex compare in terms of size? I'll do the same thing. Click on the Mac first, and then click on the Spark. They're both thinking. You can see that chart on the top there? It just spiked up right there. And boom, that's already done. And this one is still drawing. So the Mac definitely won there. So yeah, that's a really big difference in decode. I imagine if this was the Ultra, this would be much faster as well. But look, the data is actually a lot here, right? They're actually showing a lot of data. I just showed us a lot more information than the Mac, which, oh no, it's about the same. This one had a table in the end. Let's do another one. In case these giant theropods coexisted, and the other one is what evidence. Let's click that again. Click, click. It's a lot of thinking. We're both still thinking. There we go. The Spark finished thinking first. It's drawing it out on the screen. That looks like 50, 60 tokens. But then boom, see that? Lightning, all done. Now it's still going. So clearly we can see how much faster the Mac is, or at least having a model fine-tuned for hardware. Now let's do something a little different. Let's create a new chat here, and let's actually open a file. So let's test RAG, or Retrieval Augmented Generation, and let's see what it's like when you're actually running Python. So here, let's open up a file. The same file. It's going to be it's a 2 megabyte file, 1K rows, 1,000 rows of Airbnb data. 1K rows. These are exactly the same file. And the query is, using the attached CSV file, write and execute Python code with pandas that, number one, loads the file directly and prints the total number of rows and columns, computes the mean, median, min, and max for the price column, and reports the top 3 most common room type values. Show me the actual executed output, not just the code. Okay, so the reason why I'm stalling here a little bit is I know that it's going to actually take a couple of, maybe up to a minute or so to load up the file into memory. And while we do that, I'm going to open up a Gemini window and do exactly the same query and see what it finds, or see what it returns, just to kind of showcase the speed. Now see, it's really fast to load it up on Gemini because yeah, I'm competing against maybe 1,000 times the computing power, and much higher optimization. And I'm probably not using a 35 billion parameter model. It's probably something's fine-tuned. And what we're interested in looking for here is the speed of the decode, which is fast, and the quality of the output. So 999 total rows, 79 total columns. The mean, median, min, and max are all properly calculated. And what we're going to do is compare these numbers with what we get when this finishes loading up, and kind of compare there. Okay, so here on the Mac, it's actually completed loading already. And on the DGX, it's still going. So we're going to wait for that for a few more seconds while it loads. And while that's going, I've had a lot of feedback that people actually like seeing these cores go, so kind of look at that as a screensaver. It's actually really fun to watch it. Notice here, again, we're opening up a file with a lot of information in it, relatively speaking. So look here, all the cores are running hard, right? There are 20 CPU cores for the DGX Spark, and each of them are running at least 60%. Yeah, we're running consistent on the memory end of things. However, to grab all that information and do some encoding or decoding inside of a file, I think it's a lot of memory usage. It's still running, so I'm just going to keep talking here for a little longer. Here on the Mac, the main area that we're looking at here is the color there, to make sure it remains green. Because the moment that becomes yellow, it gets a little scary, and then it's not a fair comparison anymore. But for now, we'll look good. Okay, the file has completed loading for both. So we're going to now compare it and see what token speed looks like for actual code. So I will set the mice on top. Press there. There we go. See the plateau there popped up? And here, same thing, plateau. But they're both still thinking. Again, the query is to actually write and execute Python code that's going to load the file directly, print the number of rows and columns, and compute some statistics, and then show the top 3 most common root type values. So here it's actually showing that it's reviewed, got a timestamp, it's reviewed the files, and it's now executing the code. And on the Mac, it hasn't done anything yet, but the Spark has already spit out all the information. Now, is it correct? I don't know. We're going to have to check that. But let's wait for this one to pop up. It's still going. Again, the main difference, right, is prefill is much faster on a Spark or a DGX system, and decode is much faster on the Mac. And there we go. It's also showed the calculations. Now, here's where it really matters, and let's take a look at the quality of the results. Where was that results page? Oh, okay. So the results that we saw from Gemini. So look here. I don't care if it's fast, but it has to be correct. I mean, it needs to be fast and correct. If it's fast and incorrect, not as great. Okay. Total rows 999, total columns 79. Here, total rows 999, 79. That's correct. The mean 21136, 21136, 21136. Median, min, max all look correct. 3 most common room types, 677, 307, and 15. 677, 307, 15. So yeah, the data is correct, and they all came out formatted nicely. But as you can see, right, the decode speed is much faster on the Mac, but the prefill is almost immediate on the DGX. Let's do a follow-up. It says, can you calculate the average price for each room type? Average price for each room type. Okay, so I want to make sure it's the same query. So here it's number 3, and here it's number 1. I'll click the Mac first. I'll click the DGX next. I'm thinking. Boom, so it's already calculated it, and this one also calculated it. So in terms of time, they both come out end to end around the same time. One just spits it out slower, but starts to spit it out faster, and the other one takes slower to spit it out, but when it does, it's blazing fast, right? So that's kind of what I wanted to highlight and what we expected to see when it comes to prefill versus decode. So we'll stop there, but yeah, Qwen 3.6, 35 billion parameters, quantized down to 3 billion active, 4-bit, between the DGX Spark and the MacBook Pro with an M5 chip and 48 gigabytes of VRAM. Thanks for watching.